Hello students. Next example. Does there exist a binary tree on 11 vertices with only 4 pendant vertices? Justify your answer. We know that binary tree on n vertices has n plus 1 upon 2 pendant vertices. Binary tree on n vertices has n plus 1 upon 2 pendant vertices. For binary tree on 11 vertices, here n is equal to 11. 11 vertices has 11 plus 1 upon 2 pendant vertices, means 12 upon 2 is equal to 6 pendant vertices. So this does not exist 4 pendant vertices. For 11 vertices there is 6 pendant vertices. So this statement is not true. Therefore this does not exist. This means binary tree does not exist which has 11 vertices with 4 pendant vertices. Does not exist 4 pendant vertices. Now this is done. Next point, tree traversal, in which first we have to know what is meant by order rooted trees. Order rooted trees are used to store information. It can be used to represent various type of expressions such as arithmetic expressions involving numbers, variables and operations. For example, this is the order rooted tree where A is root and B, C, D are nothing but the subtrees. The order rooted tree T. This is the diagram of order rooted tree. Next point, preorder traversal. Preorder traversal means let T be an order rooted tree with root R. If T consists only of R, then R is the preorder of T. Otherwise, suppose that T1, T2 and so on Tn are the subtrees at R from left to right in T. The preorder traversal begins by visiting R. It continues by traversing T1 in preorder, then T2 in preorder and so on until Tn is traversed in preorder. Following figure indicates how a preorder traversal is carried out. Here this is nothing but the order rooted tree. Here R is root. First take R. Step 2, visit T1 in preorder, and in step 3 visit T2 in preorder, and for T3 means step 4 visit T3 in preorder. First visit R, then visit T1, T2, T3. Now next is example on the preorder traversal. In which order does a preorder traversal visit the vertices in the order rooted tree T shown in the following figure? The steps of the preorder traversal of T are shown in this figure. Now we traverse T in preorder by first listing the root A. First listing the root A, followed by the preorder list of the subtree with root B, followed by root C, then followed by root D. Now first preorder traversal, visit root, then visit subtrees left to right. First this is the root of this order rooted tree, so first visit root and next visit subtrees. Here first subtree, second subtree and third subtree. So B, E, F, I, J, M, N. Next subtree C and next subtree D. H, K, L. Now this is the first preorder. Next step A as it is. Next root for this subtree is nothing but this separate tree, separate order tree. So this is the root and this is nothing but the subtrees, first subtree and second subtree of this binary tree. So first take root B, next take subtree I, J, M, N, and next subtree this F, and next as it is C, and next this is the root, take first and next take these two subtrees G, K, L, H. Now just a minute. Next take A, B as it is. Now this is the separate order rooted tree. E is nothing but the root and this nothing but the subtrees of this tree. So first take E, next take I, next take J, M, N, next F, C, D as it is, F, C, D as it is, and next G is the root and K, L are nothing but the subtrees. So first take root and next take subtrees and H as it is. Now next A, B, E, I as it is. This is nothing but the tree. First take root J, next take subtrees M, N, and next F, C, D, G, K, L, H as it is. F, C, D, G, K, L, H. This is nothing but the preorder traversal. Okay. A, B, E, I, J, M, N, F, C, D, G, K, L, H. Okay. Now, next point, inorder traversal. Inorder traversal. Inorder traversal means let T be an order rooted tree with root R. If T consists only of R, then R is the inorder traversal of T. Otherwise, suppose that T1, T2 and so on Tn are the subtrees at R from left to right. The inorder traversal begins by traversing T1 in inorder, then visiting R. It continues by traversing T2 in inorder, then T3 in inorder and so on, and finally Tn in inorder. Following figure indicates how inorder traversal is carried out. This is nothing but the order rooted tree. First, this is nothing but the root and T1, T2 and so on Tn are the n subtrees. For the inorder traversal, step first, visit T1 in inorder and then visit root and then visit T2 and so on, then visit Tn. This is nothing but the method of inorder traversal. Now, next is the example. In which order does an inorder traversal visit the vertices of the order rooted tree T dash in the following figure? This is nothing but the order rooted tree T dash. For the inorder traversal, we take first subtree, next we take root and next take subtrees. Here you can see that A is the root, this is the first subtree, this is the second subtree and this is the third subtree. So first visit B, next visit root A, next visit C, next visit D. So first take first subtree B, E, F, I, J, M, N, O. Next root A, next remaining subtrees C, D, GH K L. Now this is the separate order rooted tree and this is the separate order rooted tree. So for the Inorder traversal, take first, this is the subtree, this is the another subtree of this order rooted tree. So first take this subtree, then followed by root B and then followed by second subtree. So first take E, I, J, M, N, O. Next root, next subtree F, A, C as it is. And for this order rooted tree, first take this is and next root and next subtree. So G, K, L, D and H. Now next take J, next root E and next this is the subtree. This subtree J, M, N, O and B, F, A, C as it is. B, F, A, C. Next take K first, G next and next L, L and D, H as it is. Now take J, E as it is. First take M, next take J, next N, O and remaining as it is. B, F, A, C, K, G, L, D, H. So the order of Inorder traversal is nothing but D, J, E, M, J, N, O, B, F, A, C, K, G, L, D, H. Okay. Now next point, post order traversal. Next point is post order traversal. Just a minute guys. Post order traversal means let T be an order rooted tree with root R. If T consists only of R, then R is the post order traversal of T. Otherwise, suppose that T1, T2 and so on Tn are the subtrees at R. From left to right, the post order traversal begins by traversing T1 in post order, then T2 in post order and ends by visiting R. Following figure illustrates how post order traversal is done. So, first step, second step, 3 nothing but D, visit subtrees and last visit root R. Step first, visit T1 in post order. Step 2, visit T2 in post order. Step 3, visit Tn in post order and last step n plus 1, visit R. Now, example, in which order does a post order traversal visit the vertices of the order rooted tree T double dash shown in the following figure? This is nothing but the order rooted tree. पोस्ट ऑर्डर ट्रॅव्हर्सल साठी आपण अगोदर सबट्रीज व्हिजिट करतो. आता ह्या ऑर्डर रोटेट ट्री साठी सबट्रीज फर्स्ट हे आहे, सेकंड हे आहे आणि थर्ड हे आहे आणि रूट ए. फर्स्ट आपण काय करणार, सबट्रीज ट्रॅव्हल करणार, मीन्स हे ट्रीज ट्रॅव्हल करणार आणि लास्टला ए पुट करणार. सो पोस्ट ऑर्डर ट्रॅव्हर्सल, फर्स्ट सबट्री टेक बी ई एफ J, N, O. Next C, next subtree D, G, H, I, L, M and last root A. And for this order rooted tree, post order traversal is nothing but the first take subtrees and last root, means first take E, J, K, N, O, F, B, C as it is. For this first take subtrees, this and last take D. G, L, M, H, I, D and last A as it is. Now next nothing but D. First take subtrees J, K, N, O. Last take root F.B.Sc as it is F.B.Sc. Now take L.M. and last take root G, L, M, G, and remaining as it is H, I, D, A. Okay. Now take J as it is. Take N, O, root as it is K. Remaining as it is E, F, B, C, L, M, G, H, I, D, A. So the order of post order traversal is nothing but D. J, N, O, K, E, F, B, C, L, M, G, H, I, D, A. So Inorder, postorder, preorder traversal. First preorder, next inorder, and third is nothing but the postorder traversal. Postorder traversal, preorder traversal means in preorder पहिल्यांदा आपण रूट घेतो, त्यानंतर आपण सबट्रीला ट्रॅव्हल करतो. प्रीऑर्डर ट्रॅव्हर्सल आपल्याला ते सांगतं. नेक्स्ट इनऑर्डर ट्रॅव्हर्सल आपल्याला काय सांगतं? फर्स्ट टेक तुम्ही जो सबट्री असेल तो सबट्री घ्यायचा, त्यानंतर रूटला व्हिजिट करायचा आणि त्यानंतर उरलेले जे सबट्रीज असतात त्याला व्हिजिट करायचं. इनऑर्डर ट्रॅव्हर्सल मध्ये ते आहे. त्यानंतर पोस्ट ऑर्डर ट्रॅव्हर्सल मध्ये आपण काय बघतो? आधी आपण सबट्रीला ट्रॅव्हल करतो आणि नेक्स्ट आपण रूटला व्हिजिट करतो. हे आपल्याला पोस्ट ऑर्डर ट्रॅव्हर्सल मध्ये सांगितलं जातं. नाउ वी विल सी नेक्स्ट पॉइंट, प्रीफिक्स नोटेशन. Prefix notation means prefix form of an arithmetic expression is obtained by traversing its rooted tree in preorder. Expression written in prefix form are said to be in Polish notation. Polish notation is sequence of constants, variables and mathematical operators in which exponentiations means exponential proceeds multiplication and division which proceeds addition and subtraction. means prefix notation आपण जेव्हा सॉल्व करणार आहोत तेव्हा सगळ्यात अगोदर आपण एक्सपोनेन्शियल सॉल्व करणार, त्यानंतर डिव्हिजन मल्टिप्लिकेशन सॉल्व करणार आणि त्यानंतरच आपण ॲडिशन आणि सबट्रॅक्शन कडे जाणार. नेक्स्ट एक्झाम्पल, if the Polish notation of a mathematical expression is like this, subtraction, this is nothing but the sign of exponential and ABC, then find mathematical expression. This is nothing but the Polish notation of a mathematical expression. Now first take Polish notation. Now first we solve by exponential, so first take two numbers A, B, C are nothing but the numbers. So subtraction as it is, A, B exponential take as A raised to B and C as it is. Now take subtraction of these two numbers. A raised to B gives a sum number, means one number, and C is another number. So subtraction between these two numbers like this, A raised to B minus C. Okay. Now next example, what is the prefix form for the expression? Prefix form means order rooted tree of the given expression we have to find out. So ordered rooted tree of the given expression is, now you can see that this is the expression, this is the one term, this is the another term, and these two numbers has a relation nothing but the addition. So first take addition as a root. Next, now this is one number, x plus y gives a one number, 2 is another number, and there is relation between these two number is nothing but the exponential. So first take exponential. Now take exponential is the relation between 2 and x plus y. So take here addition, and addition is in between x and 1. So next is division. Now division is in between x minus 4 and 3, means 3, and x4 are nothing but the two number. Here x is variable, so x has some number and 4 is another number. So subtraction, and x is here and 4 is here. So this is nothing but the order rooted tree of the given expression. Now to find out prefix form, we have to first find out order rooted tree. Here already one process is done. Now to find out prefix form means preorder traversal. So prefix form is nothing but the first we travel this, next travel this, and next travel this. So when we travel, we get prefix order, means prefix form like this: addition, exponential, again addition, x by 2, division, minus x4 3. This is your job to find out prefix form. Now next example, what is the value of the prefix expression? Now this is the prefix expression, and in Polish notation there is one node: first solve, exponential next solve, division next solve, multiplication next addition, and subtraction. And also here is hint: for the prefix form we travel right to left. To find out order we travel left to right. To find out value we travel right to left. Here the side of right. So first write down prefix expression: addition, subtraction, multiplication, 2, 3, 5, division, exponential, 2, 3, 4. First here you can see that exponential and 2, 3 number. So first addition, subtraction, multiplication, 2, 3, 5. Star means multiplication. Division as it is. 2 raised to 3 for this. 2 raised to 3 nothing but the 8. So write here 8, 4. Now next division for these two number. So for division 8, 4 is nothing but the 8 by 4 is equal to 2. So addition, subtraction, multiplication, 2, 3, 5, and write 2 for this. Now take multiplication for these two number. So addition, subtraction as it is. For star 2, 3 nothing but the 2 into 3 is equal to 6. So write 6 here, 5, 2. Now subtraction, take these two number, addition as it is. Minus 6, 5 is equal to 6 minus 5 is equal to 1. So write here 1 and 2 as it is. So addition for these two number is nothing but the 1 plus 2 is equal to 3. Therefore value of this expression is nothing but the 3. Therefore value of this expression is equal to 3. यामध्ये लक्षात काय ठेवायचं आहे, तुम्ही डिव्हिजन, एक्सपोनेन्शियल, मल्टिप्लिकेशन, ॲडिशन, सबट्रॅक्शन घेत असाल तेव्हा आपल्याकडे दोन नंबर पाहिजे. म्हणून आपण जे पुढचे आता इथं बघू शकता तुम्ही, आपण एक्सपोनेन्शियल यूज केलं तेव्हा आपण 2, 3 पुढचे जे दोन नंबर आहे ते यूज केले. सिमिलरली फॉर डिव्हिजन पुढचे दोन नंबर यूज केले. सिमिलरली फॉर मल्टिप्लिकेशन, ॲडिशन अँड सबट्रॅक्शन. नाउ नेक्स्ट एक्झाम्पल, draw the arborescence for the following expression: 5x plus 8 into 7y cube minus 2 raised to 7. Hence write the corresponding prefix expression. First, given expression 5x plus 8 into 7y cube minus 2 raised to 7. For the prefix expression we have to first find out preorder, traversal or order rooted tree. Not a preorder traversal, but first we have to find out order rooted tree of this expression. Now first 5x plus 8 means 5 star x plus 8. Okay, now relation between these two terms has nothing but the multiplication. Next 7 star y exponential 3. Okay, minus 2 exponential 7. Now you can see that root nothing but the multiplication, subtree is nothing but the, this is one subtree, this is the another subtree. First take root star, next subtrees. In subtrees, first relation is addition for 5x plus 8. 8. Addition is in between 8 and 5x. 5x means multiplication of 5 and x. Now next is nothing but the exponential between these two terms. So first take exponential, and next exponential is in between 7 and subtraction of 2 and star between means multiplication between 7 and exponential between y and 3. This is nothing but the order rooted tree. Now prefix form, here we get order rooted tree. Now it is easy to find out the prefix form, and this is your job to find out. Prefix form means preorder, traversal. Now prefix form is nothing but the star addition star 5x8 exponential subtraction multiplication 7 exponential y 3 to 7. This is your job to find out prefix form. Here I only give you the last answer. Now our syllabus of graph theory is completed. This is our last point of last chapter of trees. Now graph theory syllabus is completed. Here we stop.